some math revision sheets for the graph question. And the first things first, what is a function? It's px plus 2 over e to the power of px. What is a domain? Well, it'll always be x is member of reals, because we can put any value of x in here, and that e will still give us a value. To put in a function into the calculator, write f of x comma p, because we have two values here, x and p, two variables, and then we do control Jimmy button, and then we put in our p times x plus 2, don't forget times x, over e, don't put any e, put the variable e letter, p times x. Now we're done, we can move on. To sketch your graphs, you open a graph mode, you put in a function again, put different variable letter, for example, l instead of p, so it will be equals, so it will be f equals l times x plus 4 over e to the power of l times x. Next, you press menu 1b to get the slider, which looks like v1 equals 5. You change v1, you change to l, then you press menu 4-1 to change your graph view to make it look like it's on your sheet. And then what you do is you change your L on your slider, you change it to 0 and change it to 1, and then you can just sketch your graph for your page. To find the possible x-intercepts and y-intercept for f0, there are no x-intercepts we can see from a graph, but to work it out, press menu 3-4 to get function of zeros. And what you write is you write zeros of f of x, comma, 0, close brackets, and do comma x. Now what this means is that means that p is 0 because we're looking for f0, x, and we write comma x because we want it to be defined in terms of x, and the answer is we get nothing because they're none. For the y-intercept, just put f00 and that's 2. Do the same things for f1 for question D, and you should get 0 value here, you should get it to equals -2, and for the y is 2. Okay, for the question E, find vertical and horizontal asymptotes. There are no vertical asymptotes because of the domain, because x is member of the reals, and there are no exclusions, so there's no vertical asymptote. For the horizontal asymptote, you need to write lim of x tends to infinity of f of x comma 1. And that's basically all you write here. I don't know if these brackets are needed, but anyway, to get lim x thing, press menu 4-4. To get infinity sign, press pi sign down there on your calculator, and then just find the infinity sign. Show that all p have a point in common and give its coordinates. Well, f00 was 2 and f01 was 2, so if we put in xp, it should get a point for all p. So to show this, we write f of x comma p, and we get 0 comma p, and we get 2. So the point is 0, 2. I don't know why we need zeros. Wait, let me just check quickly.
Next question G, find the stationary point for f1. What is the stationary point? Well, you have a graph like that. That's the stationary point, that's stationary point. That's max, that's minimum. So, what's stationary point? It's when f dash of x equals to 0. How to do this? We write in zeros, comma, d over dx, which means we just differentiate this, of f of x, comma, 1 because it's f1, close brackets, comma, x, close brackets. That's the whole thing you need to write, and the answer is -1. How to write it? 0 is menu 3-4, d over dx, menu 4-1. Now, when you got this, you still gotta find the y value, so you just put in f of -1, comma, 1. The answer you will get is e. So your stationary point up here is at the values of -1, comma, e. Okay, next slide. Okay, G2, find and classify any stationary points of all p. And you just do the same thing as before, except you replace one with p, so zeros of d over dx, so open brackets f, x, comma, p, close bracket, -1 over p, and that's what you get. And then you can store it to a or something, and then to get your value, you could do f of a comma p, and x equals 2e. So your answer is -1 over p, comma, e max. H, at this point, at the point where x equals 0, fp has a tangent parallel to blank, blah blah blah. Calculate p. Okay, so we need to find a p. What does it mean basically? At the point where x equals 0, yeah, it has a tangent, the line is a tangent which is parallel to some other line. So then we need to find at what p is it? F of 2 or f of 6? Okay, so to calculate p, we need to find I have no idea. Okay, so we enter in the calculator, enter. So basically first we rewrite this, so write y equals -8x plus 3. Okay, in the calculator we enter zeros, open brackets again for some reason, d over dx, open brackets, f of x, comma, p, close brackets, do a little sign here, I'll show you how to do it in a moment, x equals 0, close brackets, plus 8. This plus 8 comes because there was -8 here, and then comma, p. Now see, here we defined x, so we're not looking for x, we're looking for p, and so we say we are looking for p here. And the answer we get is 8. So that's it. How to get this little sign, don't confuse it with modulus, is you press Control plus equal sign, which is next to the trig sign, next to the trig, and that's how we get, and you get this little thing. So the answer is 8. For h2, find the equation of its tangent. So if x equals 0, then y equals 2 because it's same for all p, we defined it before, and m equals minus 8 because it's parallel to a line that. So if we say y equals mx plus c, then c equals y minus mx. So we find out it's 2 minus 8 times 0. So it's just 2. So the line is y equals minus 8x plus 2, right? Okay, next question. Lines and I pass through the origin and normal to fy, calculate coordinates of these 3 points with 3 significant figures. Because they pass through the origin, we know that c equals 0, right? Because if it was like 1, at 1, it had the c of 1, so if it's 0, it's 0. Anyway, okay, so what we do here is we know that the normal, normal is minus 1 over mx plus c. Yeah, that's the function of the normal line. So if we want to find c, we do c equals y plus 1 over mx, right? That's what we do. Now, since we know c is 0, we can use it in a zeros function to find what x is. So we write it zeros, open brackets, okay, y, which is f of x comma p, right, plus 1 over, yeah, right, get this now, d over dx, because we're looking for gradients, of f of x comma p. No, oh, messed up here, I think. Sorry, big time. Fuck my life. It should be x over amp here, so it should be x here, and that's correct. So it's 0's f of x comma p plus x over dx of f open brackets x comma p. And then we close this all and do comma x. You can always do comma x. Okay, I'll just rewrite again. So it's 0's of f x comma p plus x over dx of f of x comma p. Yeah, close brackets twice and then do comma x, and that's it. Yeah, okay. So, and that's y equals c equals y equals plus x over m. Okay. So once we do it, we get the answer of 3 values. Yeah, so we get like value 1, value 2, value 3, and we can just put it into f of and we store it to like a, and we put an a comma 1 to get our y values. And that's it for this question. And then for J part 2 is find the equation of these lines. So we know they have no c because they go from the origin. So we just have to find m. What's m? It's just 1 minus 1 over the m of tangent. Yeah. And tangent is just basically if it's a line, tangent has got the same m as the thing. So what we do is it's minus 1 over d over dx of f of x comma 1, I think. I might be messing up here though. Well, anyway. And then where again it's not modular signs, where x is 0. And the answer we get is like 3 values, value 1, value 2, value 3. And these are correct, and just simplify them to 3 significant figures. And that's it, that's your answer. So thanks for watching, have a good exams, and chill out.